Hi, it's Gadget UK here again, another wide computer here. It's an Amstrad CPC. It's an early version this, I think. And I think the clue is the logo's different. The ones you've seen on my channel have got like a band or something through here. I forget exactly which way it is. It's slightly different. So that's the first clue, but also the keys feel a little bit higher. You know, if you look at them, they look raised a bit higher. I may prefer the older keyboard. These feel just a little bit clunky compared to the later one, perhaps. It's like there's a bit of resistance occasionally. It might be because it's not been used in a while, but anyway, yeah, there is a subtle difference. And even the print here looks subtly differently as well, actually. You can see it does need a bit of a clean and retro bright though. Can you see the side of that key there? It's nice and blue, and then the top is faded. So yeah, I'd be tempted if this was mine to obviously take all the keys off, and I showed this in the first CPC video. I'll stick a link up there to that. Pull all the keycaps off, clean them all in the sink, and maybe retro bright the coloured ones here, because they'll just come out a little bit better. And obviously with it being a 464, it's got the cassette deck here as well, so again it's looking very dusty and dirty in there. I'm not going to do a complete restore on this because this isn't mine. This has been sent from Rich, actually, a friend of Novabug. It was Novabug contacted me and said, my friend Rich has got a CPC with a fault, would you mind having a look at it? And I said, yeah, no worries. You can see the eject button there's taking a bash. That's jammed in, look. That's going to need, oh there you go, I was going to say it's going to need, I think it is, it's going to need a fix, because that is totally jammed. So we'll perhaps have a look at that as well. I may as well clean up that bit of plastic while I'm there. It's not really much effort to take that out and clean that, and we'll just have a bit of a wipe over it, but this is not going to be a full restore. Anyway, I'll show you what this is doing. So we connect it up via RGB, switch it on, purple screen. Now the thing is with this, if you switch it off and on, you'll see, in fact it's not doing it now. We're getting like lines and blocks, and there you go, little bits of lines. I think maybe it's a RAM fault actually. It might not be. Could be something wrong with the graphics chip, or you know, the VDP, whatever it is. The what's it called on this? The CRT controller. Could be that. It could be anything really. It could just be corrosion on the board, or a gate array problem or something. But anyway, I'm going to start by just taking the lid off and having a little bit of an inspection, and I might just try the piggyback approach at testing the RAM. And I just noticed, can you see these here? Do you know what those are? Those are tooth marks from a cat. One of the cats obviously spotted this last time, and there as well, look at that, right on the blooming connector. Last time this was out, I must have left it disconnected and the cats have got hold of that, so just watch out for that sort of thing if you've got pets. Anyway, I can change that connector pretty easily if it bothered me. It's just been marked by the cats, hasn't it? Clearly they've claimed it. They're not just happy with their territory, they now want possessions within the house as well. It'd be interesting to see what board's in here. Is this going to be a long board? I suspect it might be. But you never know, it might be a later model. I could be talking rubbish. You know, I don't really know all the different models here for the CPC, but what I do know is there are a number of different board revisions, like 3 or more, probably 4 or 5 I think, maybe even 6 or 7. And Yellow Belly actually covered a couple of repairs on his channel. One of them was the sound chip. You know, the keyboard was an issue. Let's just try and carefully rotate this way. Yeah, so check out his channel. I'll post some links down below to that. He's not an expert, as he admits himself. He's there's the 6 screws. Yeah, I'm just wondering what's holding it on, because the screws are all out here now. Something on this side here is, oh there you go, it's just sticking a little bit. So let's just tilt this up here. Yeah, it's totally different look. We've got the tape connection here. Let's just pull that off. And across this side here we have the keyboard. Now it looks like you've got to unplug it from the keyboard itself. That looks like the bit you disconnect there. Let me just try and carefully pull that off. I'll tell you what, let's not bother about that. Let's just tilt this up on its side. Yeah, you can see it better there. Can you see I start to pull it out on one side, look, and not on the other. So yeah, it's definitely one of the longer boards. There seems to be a lot less on here than there was on mine, I'm sure. You can see the RAM here. T, is that Toshiba? I think this may have Toshiba RAM, and it's got a heatsink there on the gate array. I hope it's not a faulty gate array on this. And we've got some corrosion on the back here as well. Something that just caught my eye, look at that resistor there. That's been well and truly squished at factory, hasn't it? It's not been soldered on there straight. So yeah, we can correct that, I guess. Anyway, the next thing I'm going to do is just test the temperature of these. We can access all 8 of those there without taking that off. Let's just connect the power up. I'm not sure if the power switch is... Yeah, the power switch needs to be connected here. I think, and this is something I learned from watching Yellow Belly himself actually, on some of these boards like this one here, the power comes from the tape side, it comes from the right over there, the power switch, it's not the back up there, that's the difference. And using a DuPont connector, you can just connect pin 1 there to pin 3, I believe, and that will switch it on. So I'll just go and see if I've got a pin header I can connect. I think I have, I've got one actually, a socket to socket, DuPont to DuPont, so let me just go and find that. Yeah, here it is. This is the wire we use with the Amiga Booty McBooterson, the A2091. And we can literally just go from pin 1 to pin 3 there, and that should power it on. Let's just connect the power and video up first. Yeah, so joining pin 3 there, you can see that I switched it on. So yeah, I learned that from Yellow Belly. If you're learning that from me, you've learned it from Yellow Belly. Because this is the first time, well, I've looked at one like this before. I think this is the same model I fixed as my very first CPC repair, to be honest. Yeah, but it's an awful long time since I worked on that very first CPC. But it would have had a... it was the same model, is the point I'm trying to make. And I think when I tested it back then, I didn't bypass the switch like this. I would have just been testing it with the thing connected. Anyway, yeah, I'm thinking RAM. So I've unclipped the heatsink there and tested all of those RAMs that way. It's not revealing anything at this stage, so it could still be a RAM fault, but I think the next thing I'm going to do is just get the screws out so I can have a look on the underside of the board. You know, there's 1 or 2 dark wires here. It could just literally be a bit of corrosion or something, so I'd like to have a look on the underside. And you can see I did disconnect the keyboard here. I just pulled with my nail here on both sides, and that just came off the keyboard connector. So let's just get the screws out that hold the board in. And there's a good, I don't know, 9 or 10 or more of these around here. They're very obvious, they're in square boxes, look on the silk screen. So I'll show you, I'm seeing strange things straight away on the very first chip I'm looking at here. I've got the logic probe connected. I'll show you where, well, you can see on the bottom of this resistor here, that's the ground, and the bottom of this resistor here, that's 5 volts. If we look at the VCC rail, can you see it's going red there, it shows it's got a high, 5 volts. Looking around the first chip that I landed on here, I haven't checked anything else. And that feels warm. It's not boiling, but yeah, it is warm. Anyway, the first chip I've landed on, if you look at the first, well, not really the first, but one of the gates up here, it's the last gate on this chip. Its input, that's an OR gate this, and it's pulsing. We've got green and red. The next input is green and red. So we'd expect to see at least a red, you know, a high, or pulsing, and it's actually floating. And I've, you know, made sure the pin is alright, it's just completely floating. And that's the output. So straight away we've got an issue there. I'm wondering if this now the coincidence of landing on this is the very first thing I've tested leads me to wonder if this has been overvoltaged. There might be more than one thing faulty. It could be 2 or 3 or more parts faulty, but that certainly does not look right. I'm just going to piggyback that with a, because the output is high impedance seemingly, I'm going to piggyback that with another 32 and just see if that makes any difference. So you see what we get on the output there when it's piggybacked. Well, would you believe it? I have fixed it already, and I swear on my life, this is the first chip I landed on after looking at the RAM. That is one hell of a coincidence. There's no corrosion or anything here, but just measuring connectivity there after working out that this is the problem, this here was a bit corroded around there. Anyway, I did wonder if that was going to be the issue, but anyway, I then piggybacked it, and if you remember rightly, it was this 4th pin here. You can see it's now high, and that's fixed it. I can't believe it. I swear. I tell you, I'm developing some sort of inner sort of sense towards faults, because it's like I looked at the board and I went, That LS32, let's have a look at that. And then lo and behold, that's what it was. That is just incredible. That is just the most luckiest thing I've had recently. Let's just try cycling the power. Make sure it wasn't a fluke. No, that's it. I fixed it. Thanks for watching. Catch you in the next video. So let's get this over to the mat. Let's get that chip off and swap it out. That is incredible. Seriously, I'm gobsmacked. Absolutely gobsmacked. All of the chips that are on here. The first one I logic probe and go, there's a problem there. And that happens to be the issue. That is just amazing. I've got a guardian angel, I'm sure. It's like whispering in the ear, telling me what to look at. Anyway, yeah, let's get that off. So, yeah, piggyback technique. Some people don't like this. Some people go, well, it doesn't, catch everything. But when you've got high impedance signal like that on a logic gate, that will work. That is definitely the problem though, because I even cleaned up with the fiberglass pen a minute ago here, and just measured again. Nothing at all. The gate. And that gate there is not outputting at all, so that is the issue. Now, what's contributed to that? I'm thinking corrosion. If you look up here, can you see the pins on that just look a bit weathered, and it's this pin up here. So if some corrosion has got around there and stuff, maybe that's killed it. It could be the 273 that's killed it. We'll need to obviously test for a period of time to see if it's a lasting fix. But anyway, let's get over to the mat and remove that chip. So it's this chip here. I am still in shock. Seriously, I am. What is going on? How does that work? How do you just look at the board and go, that chip maybe, and then find that actually is? I'm developing a spidey sense, I think that's what it is. I've got a spidey sense for faults now. Because the other thing is, there's no clue. There's no clue that was the issue. None whatsoever. It literally could have been anything on here causing the fault. So that's just a bit of good luck, I think. But you know what? I can live with good luck. And give me good luck every day of the week. Unfortunately, life doesn't usually work out like that, does it? Anyway, you can see I'm just using the desolder pump here. Engineer. I've got a particle of solder there. Oh, I've got stuff flying around here. Yeah, I always like to show using this desolder pump technique here because it's what most people can have easy, affordable access to. Bear in mind, you can do damage a lot easier doing it this way. You've got to make sure your iron is not outputting too much temperature. Pads on a board like this won't survive being overheated. That is for sure. And of course, you can always damage your chip easier, or damage the PCB rather easier doing this versus using a desolder station. A desolder station makes really light work of this. 10 seconds that chip would be off without any risk to the pads. That's power rail there, so it's going to need a little bit longer to flow through to the other side, I think. I bet that's a pretty rare fault, to be honest. It's not the sort of thing that probably fails very often on one of these boards. So let me just flip it over and inspect. So yeah, majority of the solder is off there actually. That second pin though, kind of doesn't look very free on this side. So let's just give it another go. Sometimes just wobbling the pin a little bit, being careful not to move the pad. You don't want to damage the PCB. There we go, let's free it up. Yeah, and I've had people saying you're going to lose wires and things doing this. You don't lose wires doing this. You do if you don't know what you're doing and you over stress things out here and try and wrench the chip off before the solder has all been removed. But if you're careful and patient, there's no reason why this technique can't do the job. They're not making a snapping noise, so there's still too much solder on the other side, I think. You can see I'm just grabbing them, not damaging the PCB here, and just having a little bit of wobble, and they will snap off the edge. And you won't damage the pads if you're careful, you have removed the solder. Anyway, let's just flip that over and have another look. So yeah, it's looking pretty free there. Now bear in mind, this chip I know is faulty, so I'm going to do the other thing I think I talked about in a previous video, just to push into the pin a little bit there, just to try and snap it off. You can always use hot air. If you've got hot air, now is the time to use hot air to try and free it up. But nevertheless, we'll go with the old technique that I was shown when I first got into the industry. Just see if that makes a difference. For good measure, we'll just do a bit of that again. Yeah, can you hear them snapping off? One or two snaps off there. And there. You could cut this chip off as well, because we know it is faulty. Might even do that in a minute. If it doesn't come off, come off now easily, I'm inclined to cut some of the pins on it. I'd like to try and avoid using hot air, because it might not take well to tear. So let's just carefully get the screwdriver under here. Can you see that? Look, that side's off. Let's just put it back that way. And that side's off as well. Let's just move that cap out of the way. Sometimes things like caps like that there can make it really difficult to try. Yeah, you can see that's coming up. That is, I think that is off. I've got one of my pointy tools here just to try and get under there. Yeah, all the pins are off, I think. I think it's just a question of solder on the points. Yeah, you can see that is coming off. Let's try getting under that side there again. It's like seesaw in the middle. It is out. All of the pins are out. It's probably a bit of solder here catching or something. Let's just try and straighten these. I have to keep rotating the board. Yeah, there we go. Phew, that was just a little bit fiddly to get off compared to the last one. But you can see we've got no pad damage there. And let me just show you, there is no through-hole plating on there at all. None whatsoever. So we didn't damage any wires. And you can see I wrestled that a fair bit there. So anyway, let's just clean that up with a bit of IPN cotton bud. Get a socket on and we'll swap the chip. Just to clean those. Going slightly further afield, I will give this board a wipe down. That's one thing I will do before I send it back, because look, it is pretty blooming dirty actually. But anyway, that's the bit we want to focus on just now. And get our new socket in. So pin 1 is to the left there. It's not even marked on the silk screen. Oh, there is. There's a little thing there. Can you see that little slice? So let's get the socket in. This is where you might need to remove a bit more solder if there's solder restricting the socket going in. Is it the pins? Yeah, one or two of these are just a bit bent, I think. Yeah, one or two of those just need a little bit of solder removing. Yeah, the third one there, if you hold it up to the light you can see through, and I can see that the hole there is a lot smaller than the others, and that one there again is a lot smaller than the others. Let's just do that again. And again, just which one's the wet side? That side. Just wipe over those there gently. You don't want to scratch the board and damage, pull the pads off, just because you get a little bit caught on one of them. Yeah, if you don't remove all the solder when you push it in, can you see, look, a pin will come out, so I can just pull that back off again. You can push the pins back into these sockets very easily. Just press the top down like that, and then just inspect it closely. Yeah, it's gone back in. So the second one up there, wasn't it? It pushed it out. Yeah, there we go. Finally, it's on. And as I say, just inspect to make sure they're all in properly. And you can see them all and feel them all through here. So I'll just solder a couple of diagonal opposites. Do that one and that one, and then press it from the other side and reflow, and just inspect it to make sure it's nice and straight. Yeah, that's alright, I think. But anyway, you can see that's on there. I just need to clean up with some IPA. But right now I want to go back over there, get the chip in and just test it. So there we go, HC32 in there, and yes, it's working. Fantastic. That was so easy. That has just been a dream to work on, that one. Consistent. A lot of the times when you plug this power in, it wouldn't even display anything. You had to disconnect and reconnect the power a number of times, sometimes several times, and then you'd start getting those coloured blocks and things. So yeah, I'm pretty confident that's all the issue was. So obviously I need to finish cleaning the PCB up now, clean the flux from the underside, reassemble it, and test it, test some games and things on it. But yeah, I'm confident that was it. So I'll fast forward through a lot of the stuff because you've seen it before. I'm just going to reflow the power socket here just because it does look a little bit crusty. So we'll just clean around there. There you go, so you can see that's has solved that. So we'll just clean up the rest of the board. There's a bit of flux up here that I will clean off as well. Can you see that? Just from manufacture. And look at the length of these pins here. Oh, I'm cutting those down. Yeah, there's no way I'm leaving pins that long. Can you see those? They're ridiculously long there. Is that a transistor or something on the other side? I think it probably is. Yeah, it is. It's that transistor there, look. I've got another one here, look. And one up here. In fact, there's a few up there, look. Those two there are nearly short in look. I mean, there's loads of legs like that on here. You can see all these cap legs stand out quite a long way, but yeah, anything where there's a risk, like that one there I'm going to do. Yeah, anywhere there's a risk, trim the blooming things down. And I use some paper towel here to cover the majority of the clean-up work here, and then I'll go with cotton buds and toothbrush, you can get all these bits of paper towel off it and fluff and stuff. But this is the quickest way if you've not got something like an ultrasonic cleaner, and I'll bet nobody's got an ultrasonic cleaner big enough to fit one of these boards in. Presented in widescreen. Look how dirty that is. So I've had a good go over the board there. It's not perfect. You can see I realigned that component there. The leg on this side was like really long on the other side and short on one side. It wasn't even on through on the other side. It was only on this side. So anyway, it is just a cosmetic thing, but yeah, hopefully you can see that is looking a lot better. Same thing on the underside. You saw me cleaning the flux off there before. Still a little bit of flux up here in this top corner, but the board is very clean. So the final thing before I get this back in the case is to clean this, just as you see me do before on other videos. You can see on the underside those are really clean already. The one other thing I will reflow is that via there, because it's corroded. It's through to the other side okay, just the solder's just blooming awful on top. So we'll just get that off with the solder pump and just get some fresh in there, I think. and I'll just inspect it just to make sure it's alright. Yeah, you can see now that's flowed, look, through to the other side. I don't know where that connection goes, but it's just a good idea to reflow it. So what we're not doing is a full restore here, we're just the bare essentials really. So before I stick the board back in, obviously I will just give this a wipe down with some IPA, it's a little bit dusty. But Rich could always, take the board out and then soak this in the sink and wash and scrub it all down and stuff. So one thing you'll notice that the heatsink was taken off there. One of the first things I did actually is just reseat these two chips. Before I started getting the logic probe on there, I reseated both of them. The single wipe sockets, so those could be a source of failure, but they tend to be okay in the CPC. Now what we do need to do is get that heatsink back on there, so I'm going to have to carefully prise the gator rate out again. And anybody who pipes up saying use a dip extractor here, it's a single wipe socket. You try using a dip extractor on this, you're just going to have a world of pain. You know, they really, really firmly stick into the socket here. The hole for the dear lives. You can see I'm having trouble just even prising that out because it's well and truly welded in there. There you go. So let's get that blooming awful thing back under there. It doesn't need any new heatsink compound. The heatsink compound that's on there is fine. And we'll just get the Gatorade back in, and then we can clamp this back on. Not sure where these cutouts were now. Actually, there's two of them. I think it went up here like this. And then you can literally, the way I got this off is just the bend. You can just literally bend these out. Let's just see if we can get that down a little bit and in. Yeah, there we go. That is it. It's nice and snug on there. You could, for good measure, just wipe that with a bit of IPA. You can see the surface of it is a little bit dirty, or was. Just get a bit of paper off there. There we go. So that's that done. Just get the screws back into the motherboard now. So we're all connected back up, all the screws are in place. Quick test before I connect the keyboard, you can see it's working. So this isn't really what I'm supposed to be looking at, but I'll give this a quick clean. You can see it's very dirty in there. The belt was hanging off here for the counter. The button fell straight out, so this is what's wrong, you know, it was at an angle, wasn't it? It snapped off somewhere here. So I think I'll probably just unscrew this carefully here and see if I can somehow work out how to glue this back on. There's a little hole there that looks like it should, I don't know, it should sort of fit somewhere like that. It's not working though, you know, it goes up, but the reset ain't working. Right, so super annoying because, as I say, we're supposed to be just dealing with the one fault here and it's turning into a restore because there's just so much wrong with it. Anyway, the tape counter, I've just took it to pieces and worked out that the button's broken. You know, there's a piece of plastic. I'll show you that in a second. So I spoke to Rich and he says, you know, someone with a 3D printer is going to get a 3D part printed for it. So in the meantime, I've said to him, order belts for this because the tape counter belt was disintegrated, and the main belt is going to need swapping out as well. But while we're here, we'll just clean this up now. It's, like I say, it's not going to be a full restore this, but I can't leave all that dust and fluff in there. So I may as well do this bit now, and then we'll come back in here to fit the tape counter once the button arrives. I might be able to test with a cassette in advance of that just to see if it's actually working as things stand. I'll clean the head up in a sec. We'll just collect all this fluff and dust, of which there is a lot. So whilst we're here, I'll try and clean some of these wheels and things. You know, they've got some rubber parts here. Just gently. And can you see the pinch roller there? Look at that. It's got an awful layer of brown stuff on it. What we might need to do after this is scratch this up with a piece of light sandpaper to make it slightly abrasive. That is really dirty though. You know, if you're not careful, you can make it go smooth. That is really worn. You know, I don't even know whether this is going to work, because when these rollers, when the pinch roller gets worn too much and the idler thing there, you know, it can be kind of game over for these unless you can find spare parts. And we'll clean those two heads. Look how dirty that was. It's brown. Anyway, that is more or less all I am going to do to this. There are a few bits of corrosion and stuff on here. As I say, I don't want to get bogged down with a full restore here. I'm not getting paid for this, and I could spend crazy hours working on this to get everything absolutely pristine. I would imagine most people are not going to be loading cassettes on a system like this anyway. Probably going to connect to a DDI3 or something up to the back, or a dandinator or something. But if we can get it working, great. What I'm trying to say is, I would spend a lot more time if this was a full restore. You know, and he can do these things himself, a bit of molly coat or something on these gears here. Anyway, let's just see what that's like now in terms of tightness. Yeah, it might be alright. So, contact cleaner into the switch. The switch is pretty good on that one actually. And into the pot. Right, so I've just reassembled it until the belts come. I won't bore you with the teardown again. We'll just jump to swapping the belts and the counter, I think. But I want to get this back together and we'll test it with the DDI3, I think. So we need to pull our power thing off there, and we just need to carefully reconnect that connector there. I can see what I'm doing. There we go. Put the lid back on. So you can see the counter's missing. It's a bit dirty there. We'll clean that up when I go back in to do the belts and the counter switch. So pointing at the screen, QWERTY UIOP SDFGH. I forgot how you do this now. Is it shift and small enter? Can't remember now. Control and small enter. Yeah, it's control and small enter. It's been a while since. Let's just see if the cassette deck is actually working. Yeah, it's rewinding. Might just go and get my Chase HQ tape and we can give that a try maybe. One good test to do here is press play and then, yeah, that's not working. The pinch roller here is not moving. I think it's the belts actually. Yeah, it's slowing and stopping, look. Let me just zoom in on that. You might be able to see, you can see it's stopped. Just watch, hang on. Look, it's moving, moving, moving. It'll put a stop in a sec. It's still moving just now. I think that's the sign of the belt, but this is smooth, this roller here. So we'll have to scratch that very gently with some very light sandpaper, but change the belts. But yeah, it's moving now, it's keeping going. I might just go and get my tape, we'll give it a try. So rewind and fast forward's working alright. Let's press play. Yeah, look, it is not working, is it? It's definitely the belt that's the issue. Right, so the power is disconnected. Let's have a go with the DDI3 from Zaxxon here. Really nice bit of hardware this. So it gives you, you know, a DDI disk drive emulation, a number of things actually. There's some switchable ROM options and things. You can use PowerDOS and stuff with it, and it's got 512k of additional RAM. So if I just tilt this forward, floppy disk interface is here, the other one is for the printer. So let's carefully connect that up. One thing I don't like about these is all this bare exposed circuit board. Let's now connect the power. So target Renegade is selected there. Let me just do cat. Woohoo, that worked. So I'll do run target. One thing I have noticed is this is slower than 6128. Yeah, got stereo there because of the speaker. Where's the volume? Hang on a sec. Yeah, there we go. Ah, you just press 1. Yeah, you've got to really find the keys there if you want to use a joystick, which I always thought was a bit weird on this. Looks fantastic. The colour's really good here actually. The colours seemed a bit more vibrant than they were on that last 6128 I looked at. I'm not sure why that is. There are different revisions of the CRTC, you know, made by different people, I think. Maybe that's got something to do with it. Anyway, that's working. So a few days later I have some belts from DataServe here. I've just taken this back to pieces again. I'll have to take it back, the whole unit here, the tape deck, out completely later to refit the counter. You can see I took the cap off that. I'll show you that when the new thing arrives. You know, this switch here, the button, the reset button, it's got a little bit missing off it, and that's all that's wrong. So when that arrives I can reassemble that. Anyway, I'm going to try and swap the belt out now. I've undone the 2 screws holding this board. The only thing that's inhibiting us here, stopping us from replacing this belt, is it needs to go under here, this bit. So I undid the screw here, the 2 screws here, all the screws holding the cassette deck in, and then I've just undone the screw on the side of here. You can see I've got to be careful, this is going to fall to pieces. But the idea being that hopefully I might be able to just move this, there we go, out of the way a little bit like that, and we can get the belts off and get the new one on. Be careful you don't mess this up. I need to just put that roughly in the right position there, and I'm going to swap that. Yeah, it could be some trial and error reassembling this in a minute. Let's just move that there a sec. You could clean all this, you could clean the plastic wheels and stuff here up, but I'll be honest, it's looking pretty good actually in terms of, you know, the belt hadn't disintegrated, it's just slack, that's all. So we'll get this onto the little one at the top here, I think, first of all. There we go. And then we'll try and pull this around. It's easier said than done. I'm just trying to get it onto that little wheel. Yeah, there we go. And then slide it around here, rotate it around. And that's not on. Can you see that's gone down there, look? I think. Yeah, you can see it is not quite on the smaller wheel here. It is now, I think. Yeah, there we go. So, I'm sorry you'll not be able to see very much of what I've done here at all. I need to get this back down here. Somehow screw this back in, I don't know where it went. It might never work again, this. This is super fiddly to do. Obviously it would be easier if you removed this whole thing entirely. Is that going to go in there? Where's that screwing in? Yeah, I think that's going in because it's pulling this metal piece over this way. That's it. It's just whether everything's aligned there, that is the problem. So the one that goes in this next bit, you can see it's got a flat bit at the top there. So let's try and get this back in. Well, you can see it's going round with a regular velocity there, and it does seem to be loading. It's loading chase block 1. So I plugged the joystick in. sweet. Yeah, you don't get the speech on the 64K version. Fantastic. So we're just waiting for the reset button for the counter now, and I'll just give it a clean, and then it should be ready to go back to Rich. So the replacement buttons have arrived. Let's have a look at one of these. These have all been 3D printed by a friend of Rich, and they look good actually. You can see that it's got this piece here, and if you look at the original one, you can see it's broken off. So yeah, it feels a bit bigger. That could be the problem. Is this going to fit? The way this works is it goes through there like that. Yeah, you see it's not going in. It's going to need something filing off it, I think, or something like that. So I think we are there. I'm just going to pop this back on there. I think it goes this way around. Let me just show you first. I filed it. I filed it very carefully. Can you see? Goes in and out. I also put a little bit, you can see it here, some molycoat on there just to ease, you know, assist rather, not ease. And you can see it goes up and down really nicely, and it does the reset. If we spin this wheel here, we can count it up. Let's just move it along. So you can see it's on 4 there, and if I press the reset down, it resets. So that is okay. If we just get the cover back on here, there's a recess on the right hand side here for the button. You've got to sort of get it on one side and then on the other, and then just clips on like that. So yeah, let's just try resetting that again. Yeah, sweet, that's working. So the final thing to do is reinstall it and get its belt on and test it. And it's dead simple. 2 screws hold it on, and you put the belt on, and it just goes over there like that. That is it. So yeah, you can change this belt out from the, well, the top side. You still need to obviously remove the whole thing from the lid. There we go, you can see the counter is moving. 36, 37, and if I press the reset, it resets. Yeah, this was really fiddly. I had to take it back to pieces 3 or 4 more times, and I had to file the you know, the button there and add a bit of molycoat. Yeah, but that is working now. I do need to clean around it. There's some little bits of dust and stuff around there. It's a bit dusty here. I'm going to try and take that little clear lens off. I should have done this while the thing was out, really. It would have been a bit easier, but I can certainly do it by ejecting it and then just putting a bit of pressure on the underside and trying to carefully clip it out. And we'll clean all these mucky marks from the inside of this clear piece of perspex here. Well, that loaded okay. I'm just going to use some soapy water here just to wipe over this and see how much cleaner it comes up. I'd avoid using IPA on these bits like this that are painted. I've spent crazy time on this as things stand, you know. I don't want to spend hours and hours and hours cleaning this up. Well, it's not mine, I'm not doing a full restore on it. Yeah, they're just a bit yellowed. It's not actually dirt, you know, you can see they are a little bit yellowed there, those. Yeah, it's starting to look a lot better. So with this plastic flap here, what you've got to do is get your fingers underneath here, press upwards a little bit like that, can you see, that way. Get your nail into the little gap here and just pull a little bit and it'll snap out there. Do the same thing over here in the gap, and it'll snap out like that. So you don't get any damage or anything, and you can see how dirty that is. And hopefully you can see just how dirty it is around here. So yeah, we'll clean that up and we'll clean this window with a bit of Plastex there. It should look like new, hopefully. And there's a hair gone in there, look. So I'll just use a little bit of IPA here. So I squeezed way more Plastex out of there than I actually needed. But if you look at this, can you see it's really dirty and dusty? Obviously soap and water would do the same sort of job, but this stuff is very lightly abrasive and designed for doing super polishing, you know, super shine polishing of plastics like this. It's a bit like Novus that Arcade UK recommends when he's restoring pinball machines and cleaning up all the plastics on those. Yeah, that's a bit better. And we'll just carefully get that back into place now. So the things at the bottom go like that. If we just eject this will make it a bit easier, and if I use the cloth to assist me do this, I'll have one on the top and one on the bottom. You can see I'm getting hairs and dust and stuff attracted to this already, but if I have my fingers in the bottom there, I'm not going to mark it, am I? Let's just get back in place again, and just press at the point there. You can see that's gone back in, and over this side here, there we go, back in. As you can see, that just looks so much better. That looks new. So a quick look at the motherboard from the back here. I've just cleaned around this chip here with a fiberglass pen. Incidentally, the gate that we replaced, the faulty gate on this OR gate here, this OR chip, the connection goes through to here actually, and I think it's a clock pin. We'll have a look at that in the schematics in a second. But anyway, yeah, the connections here were cleaned up. They still look a little bit flaky, but they're okay. It's a little bit of wear through. These little dots here, it's actually worn right through. There's nothing you can do about that. You could try and cover it in solder, but then you'll have an uneven surface. You want these to be as flat and as smooth as possible. So I'm all finished cleaning this up now. It's got a little bit of history on this, let me show you. So I've covered most of the label there. Can you see D Shrewsbury? And the area is Northampton, and up here in sort of that ultraviolet ink, it wiped off with the IPA unfortunately, it's had a postcode of SH1, which might be Southampton, but the thing below says Northampton. So yeah, it's very interesting. Was that your CPC? If anyone knows how to update the firmware on a DDR3, please let me know. The version I've got here now, it refreshes the screen so quickly when it's scrolling. You can't even see the title of the game. That makes it really, really hard to use. I'd like to use auto boot with it, but I just can't get it working with this. Tapper, let's have a go with that. Yeah, you can see it's listed that. And we'll do run Tapper, maybe. Amsoft, I didn't know Amsoft had anything to do with this port. That's weird, it says F1. There is no F1 key on this keyboard. Oh, there, it's 1. So, switch to joystick. So S to start. That's a great game, this. Oh, I've thrown one too many already. Anyway, yeah, the DDI3 is working. So a quick look at the schematics here. There is the gate in question on the 7.4. It says LS32. The part that was on the board is actually a HC32, and that's what I've fitted. So we've got like an IOR, is that read or something signal there, and A12 I think as inputs. Those were all right. I think we're pulsing on both of them. And the reason why I said the output we'd expect either a pulsing or a high, when you've got an OR gate like this, the way this works is if one of the inputs is high, you'll get a high. If neither of the inputs is high, you get a low. It's or, one or the other, you get a high on the output, else you get a low if neither of those are high. Now, because they were both pulsing, if they were both pulsing at exactly the same frequency, when they're both high, you'll get a high on the output. When they're both low, you'll get a low on the output. If the two signals there were out of sync with each other, alternating, inversion of each other, as they invert, you would have a high here, so you would always see a high. So, yeah, it can make, but that's unlikely. You generally wouldn't get that kind of scenario. But it can make, diagnosing things like that sometimes a little bit difficult. But you can still, apply the general logic there that it's an OR gate, one or the other is a high input for any period of time should give you a high on the output. Anyway, that was floating, our output. And it goes to the 273 here, the latch that I showed at the back. I cleaned it up towards the back end of the video there. There's nothing wrong with it though, it's fine. I did scope the signal there, it looks fine. There's nothing wrong with it at all. So why it's failed, I don't know. And the other thing is, it's not bi-directional. This latch here, it's not very clear because I couldn't get any closer on the diagram here, but these have all got arrows coming into the chip here from the data bus, D0 to D7, that way. And the output goes to the printer port. So this is basically your outputs from the printer, you know, to the printer. It's not bi-directional though, so how would that stop the system from booting? I don't think it would. I think it's a bit of a red herring. I think another gate around that same IC would have failed just the same way this one had done. If you think I'm wrong, please let me know in the comments why you think so, because it does look from this here that it's a unidirectional, single direction. It goes from the data bus through the latch out, and the signal that was related is the clock. It's the clock signal. You're actually clocking the data through here. So again, can't see how that would stop the system from booting, but that was actually the issue. As soon as we swapped that, it was problem solved. But that chip had 4 different gates around it. 174 HC32 or LS32 has 4 different OR gates on it, and there's 2 of them here you can see that generate the AOR and AOW signals, I think, and there's obviously 2 more gates perhaps used elsewhere. Yeah, we got one of them there, I think, going to another latch, a data buffer. So yeah, it could have been any of those really causing the issue in that single chip. So we're all done. It was the LS32. It was amazing that I landed on that chip. There was no planning or anything on my part, seriously. I went in with a logic probe, thought, let's have a look at that LS32. I know how LS32s work, it's a really easy one to test. And lo and behold, it was the LS32. It's just unbelievable. And obviously we replaced the little reset button here with a 3D printed part. So thank you very much to Rich's friend for getting that off in the post to me and taking the time to print a few of these. Rich said I could keep a couple, so I've got a couple, and I'll send a couple back to Rich as well, so he's got a couple of spares. Anyway, I hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.